In central tendency, we looked at a data distribution and tried to find usually a single value that represented the whole data distribution. So we were trying to move towards the central value which can be used to represent all other values of the data distribution, which was called the central tendency. In dispersion, we are going to look at all other values other than central tendency and look how far are they scattered from the central tendency. So central tendency is usually a single value that is used to represent all other values of the data distribution, or it is a single value around which all other values of a data distribution scatter. In dispersion, we are going to look at how far away are these data values of data distribution scattered from the central tendency. So again, what is dispersion? Dispersion is the scattering or spread of values around central tendency or central value in data distribution. In data distribution. Okay, one last time. While studying central tendency, we saw a single value around which all other values of the data distribution was scattering around. While studying dispersion, we are going to look at how dispersed are all these data around the central tendency. That is, how far or how close are they from the central tendency. The central tendency being either mean, median, or mode. Let me explain you with the help of an example. Here, I have two sets of data, data set A and data set B. Both of them contain 1, 2, 3, 4, 5 values, the mean for which is 80. The mean of all these 5 data or values is 50 and the mean for all these 5 values is also 80. But if you look at this graph, you can see that in case of first data distribution, the individual values are farther away scattered from the central mean value. So here's the central tendency, and the values in the data distribution are away from the central tendency. In comparison to the first set, in second set, the values are much closer to the central tendency. This is exactly what the study of dispersion tells you. And the use of it, let me give you an example. Let's say you are trying to book a hotel in a tourism area. You find two very good hotels near you, but the problem is that both of these hotels have an average review of 4 stars. Fortunately, you have someone to provide you a graph of review of both these hotels. In hotel A, here's the central value, which is 4 stars. You can see that there are also few people who have rated this hotel only 1.5. In hotel B, here's the central value or the central tendency. You can see that there is no large variation or large distance review from this central tendency, especially on the bad side. There is no bad review that is away from the central tendency. All the reviews are closer to the higher margin, higher area of review. This can help you determine that hotel B is probably better than hotel A. Now, what you are going to study are the various ways you can find out such variation in data distribution, the various ways you can measure how scattered the data in a data distribution is. Basically, you are going to learn about the measures of dispersion or the measures of variability or the measures of variation. Now, the various methods of measures of variability are divided under two categories. Ones that are used for individual observations, when individual values are given to you and then you have to find a measure of variability, and others that are used for samples, when you have group of data in the form of samples and then you need to find variability in those samples by comparing them with the standard value. So under individual observations, the measures of variability are range. Range is the simplest one of all. Range is the simplest method of all. Second, quartile deviation. Third, mean deviation. Mean deviation. Fourth, standard deviation. Standard deviation is the best method out of all the measures of variability. Again, your range is the simplest method, standard deviation is the best method, then coefficient of variation, and finally variance. All these measures are used for individual observations. But let's say you have samples, then you use standard error. Standard error is measure of variability used for samples, and there are four different types which you'll come to know soon enough. So let's go first with your individual observations. Okay. So number one under individual observations you have range. Range is the simplest measure of dispersion. It's the simplest measure of dispersion. Range is simply your maximum value minus minimum value. Another way of writing range is also minimum value to maximum value. Let me give you an example. Let's say a class contains 50 students. The maximum height in class is 6 feet and the minimum height in class is 5 feet. Then the range of heights. What? The range of heights in class is equals to the maximum height in class minus the minimum height in class, or 6 feet minus 5 feet, which is equals to 1 feet. So 1 feet is the range, which can also be written as 5 feet to 6 feet, because you are showing a range, how much to how much is the largest gap. Okay. Along with range, you also need to know the coefficient of range. Coefficient of range is simply your maximum value minus minimum value, which is basically your range, divided by maximum value plus minimum value, which is equals to, for this particular scenario, 6 feet minus 5 feet by 6 feet plus 5 feet, or 1 by 11. So this is the coefficient of range. So there are two formulae. Number one being range equals to maximum value minus minimum value, and coefficient of range equals to maximum value minus minimum value divided by maximum value plus minimum value. This is the simplest measure of dispersion. Okay. Number two, you have quartile deviation. Quartile deviation is nothing but your interquartile range divided by 2. So quartile deviation, wait, let me close the bracket. Okay, quartile deviation is equals to third quartile minus first quartile divided by 2. Coefficient of quartile deviation equals to third quartile minus first quartile divided by third quartile plus first quartile. Interquartile range is third quartile minus first quartile. That's why quartile deviation is interquartile range divided by 2. So there are two formulae that you need to know. First is quartile deviation equals to third quartile minus first quartile divided by 2. And the second is coefficient of quartile deviation equals to third quartile minus first quartile divided by third quartile plus first quartile. So let me compare the two measures of variability once. There's your range, and then there's your quartile deviation. First, range is equals to your maximum value minus minimum value, or x max minus x mean. Your interquartile range, which is similar to range, however, it deals with quartiles. So it will be third quartile minus first quartile. And the quartile deviation is your interquartile range divided by 2. Coefficient of range equals to your maximum value minus minimum value divided by maximum value plus minimum value. Coefficient of quartile deviation equals to third quartile minus first quartile divided by third quartile plus first quartile. So you can see the similarities between range and quartile deviation, especially the similarity between range and interquartile range. Okay. Number 3. Number 3 is mean deviation. Mean deviation is nothing but, as the name tells, it's the mean of all deviations. So when you have to calculate mean, what do? You sum up all the observations, right? You find the sum of all the observations and then you divide the sum by the total number of observation. Similarly, when you have to find mean deviation, you find the sum of all deviations and then divide the sum of all deviations by the number of deviations or the number of observation. Let me give you an example. Let's say there are 5 students whose marks are 20, 25, 30, 15 and 10. So these are the marks of 5 different students. And the mean of all these 5 marks come out to be sum of all observations divided by number of observation, that is 20 plus 25 plus 30 plus 15 plus 10 divided by 1, 2, 3, 4, 5, which comes out to be 20. Second, let's find deviation. What is deviation? Deviation is how much away is the mark of the student from the central mark, which is 20. How much away is the mark of the first student from the central mark? How much away is the mark of the second student from the central mark? So basically it is equals to x minus mean. So 20 minus 20, 0, 25 minus 25, 30 minus 20, 10, 15 minus 20 minus 5, and 10 minus 20 minus 10. So these are the deviations of each of the marks of these students. So first student got 20 marks. That means it is exactly equal to the central mark or the central tendency. So the deviation is obviously 0. It is neither greater than nor less than the central value. The second student got 25 marks. This means the second student got 5 marks more than the central value. The third student got 30 marks. That means 10 marks more than the central mark. The fourth student got 15 marks. That means 5 marks less than the central mark. And the fifth student got 10 marks. That means 10 marks less than the central mark. If you add all of these up, find the total deviation, it will come out to be 0. The reason being, there are few students who got 5 marks greater than central mark. There are few students who got 5 marks less than the central mark. There is also a student who got 10 marks greater than central mark. But then again, there's another student who got 10 marks less than the central mark. So overall, they will cut each other out. As a result, the total sum of all the deviations from the standard value will come out to be 0. So the total sum of deviations of each max from the standard value comes out to be 0. That is why you have to find the absolute deviation. As a result, now the minus is removed and you get all positive. Now you can find the sum of all the absolute value of deviations and it comes out to be 30. So what did I say? Mean deviation is the mean of all deviation. And the way to find it would be sum of all the deviation and divided by the number of observation. So you will get mean deviation equals to the sum of all deviation divided by the number of observation. 30 divided by 5. The mean deviation comes out to be 6. So the formula that you need to know here is mean deviation equals to sum of all deviations divided by the number of observations. Number 4, standard deviation. Standard deviation. Now, standard deviation is special. The reason being, standard deviation is the best measure of dispersion. It is the best measure of dispersion. And you can also use symbols like SD or just this symbol right here to represent standard deviation. Let me give you the same examples of 5 students who got marks of 20, 25, 30, 15, and 10 with mean mark of 20. So here the central value or the central tendency is 20. The deviation from central tendency of each of these marks obtained by individual student is D equals to 0, 5, 10, minus 5, minus 10. If you find the sum of all these deviations, it will come out to be 0. So instead, you will first square them up. 0, 25, 100, 25, 100. Now that the minus sign is gone, you can sum them all up. So this is the summation of squares of deviation from the squares of deviation of each marks from the central tendency mark. So this will come out to be 215. Second step would be you find the average of the squares of deviation and take the root of it. And this is your standard deviation. The answer will come out to be 5 if you calculate the answer. Standard deviation is also called root mean square deviation. Root mean square deviation. I think it makes pretty good sense why it's called so. It's called so because standard deviation is nothing but the root of mean of squares of the deviations. That's why RMSD, root mean square deviation. Again, root mean square deviations. So the standard deviation for this data distribution comes out to be 5. What does that mean? It means that most of the students have marks within the range of either 5 greater than central value or 5 less than central value. So most of the students have marks in between 15 and 25. That is either 5 more leading to 20 to 25 or 5 less leading to 15 to 20. Okay. Number 5. Coefficient of variability. Coefficient of variability is equals to standard deviation divided by Wait, okay. So in this case, the formula that you need to know is this right here. Okay. Now, standard deviation by mean, standard deviation by mean into 100 will give you the coefficient of variability. Let's take an example. You have class A and you have class B. In class A, there are altogether 40 students. In class B, there are altogether 35 students. In class A, the mean marks of 40 students comes out to be 20. In class B, the mean marks of 35 students comes out to be 40. In class A, the standard deviation of the marks from mean comes out to be 5, and in class B, the standard deviation of the marks of the student from mean comes out to be 2. So in class A, coefficient of variability is equals to standard deviation 5 divided by mean 20 into 100, which is equals to 25%. In class B, coefficient of variability comes out to be standard deviation 2 divided by mean 40 into 100, which comes out to be 5%. So if you compare the coefficient of variability of class A and class B, you can see that coefficient of variability of class A is more than class B. Number 6, variance. Variance is nothing but standard deviation squared. Let's say for class A, the standard deviation was how much? It was 5. For class B, the standard deviation was how much? It was 2. So the variance for class A is equals to standard deviation squared equals to 25. For class B, its standard deviation squared 4. So the variance of class A is more than class B. So that's it for the various measures of dispersion used for individual observations. Now we are going to look at the various measures of dispersion used for samples. And there's one that you need to know. That is your standard error. Standard error. Let me give you a surface view about what exactly is standard error. Let's say you have a sample of 5 students, these are the marks obtained: 5, 10, 15, 20, 25, and 30. Out of 5 students, someone gains maybe 7 marks, someone gets maybe 14 marks, someone gets 20 marks, and someone gets 30 out of 30 marks. The mean of all these marks comes out to be somewhere around here, and this is the mean of all these marks from sample number 1, and the standard deviation comes out to be this much. The standard deviation, it comes out to be this much. So the standard deviation for the first sample comes out to be this much. We do the same thing with second sample, which also contains 5 students. So you carry out the same thing with 5 different students: 5 marks, 10 marks, 15 marks, then 20 marks, 25 marks, and 30 marks. First student gets 10 marks, second student gets, let's say, 17 marks, third student gets 23 marks, and your fourth student gets around 30 marks. So the second mean comes out to be 20, and it has its own standard deviation now. This is SD2. You carry out the same experiment or the same sampling 5 different times. So this was sample 1, sample 2, sample 3, sample 4, and sample 5. After carrying out the process in 5 different samples, you will be able to find 5 different means and 5 different standard deviation. What you do is that draw the same line graph Draw the same line graph with 5 and 30 at extremities, 10, 15, 20, and 25. Now put all the means, like mean from sample 1, mean from sample 2 together. So it comes out to be something like this. So there's one mean, there's the other mean, there's the other mean, there's the other mean, and then wait, where did it go? Okay, and then finally here's the other mean. What you do, shit. What you do is find the mean of all these means. I know it's a tongue twister, but you need to find the mean of all these means. When you find the mean of all these means, it comes out to be around here, right? And then find the standard deviation of the mean of all these means. Standard deviation of the mean of all these means. This is the standard deviation of the mean of all these means. And this exactly is what you call standard error. Again, here's the thing. A class contains 5 times 5, 5 times 4, let's say 5 4s are 20. Okay. A class contains 20 students. 20 students just gave their exam and got their marks back. What you do is make a sample of 5 students 5 times. So 1 sample, 2 sample, 3 sample, 4 sample, 5 sample. Altogether 5 5 10, 5 15, 5 20, 5 25. Altogether 25 students. Right? So a class contains 25 students. You made 5 samples of 5 students from those 25 students. In the first sample, you put the marks on a line graph and found the mean and found the standard deviation. In the second case, again found the mean, found the mean, found the mean. Now you keep all these means together, and find the mean of all these means. And then finally find the standard deviation of the mean of all these means. And that is exactly what you call standard error. So standard error is basically standard deviation for samples. Whew. I hope you got the point. Even if you don't, you can just go directly into the measures. Let's look at the measures directly. Okay, so standard error. Under standard error, you have to know 4 different measures. 1, 2, 3, 4. There's your standard error of mean, standard error when there are more than 2 or more than 2 means, difference between 2 means, let's say 2 is given, then 2 means, standard error of proportion, and standard error of difference between 2 proportions. Let's look at each of them. First, standard error of mean. Let's say you have a class of 100 students where the mean marks comes out to be 25, and the standard deviation of the marks of the students from the mean marks comes out to be 5. Then standard error of the mean marks is equals to standard deviation of marks, the standard deviation of marks divided by root under n. So in this formula, as you can see, the mean marks is not even involved. So you can keep the values and find the answer yourself. Second, in second, let's say you have to compare you have 2 different classes, one with 100 students and the other with 200 students. In first, there's mean marks of 25, and in second, there's mean marks of 30. In first, the standard deviation of marks is 5, and in second, the standard deviation of marks is 2. In this case, you can apply the formula standard error of marks is equals to root under standard deviation square by n1, standard deviation 1 square by n1, plus standard deviation 2 square by n2. See, this formula comes from the first formula itself. This is how. Standard error of mean is equals to standard deviation by root under n, right? What you do is square this formula and take the under root. It means the same thing. This comes out to be under root standard deviation squared by n. And now you keep on adding more data from the right side. So you can keep on adding. Usually there are only two standard deviations that are given to calculate till n. Okay. Next. That was number 2. And the formula you need to know is this right here. Number 3. Number 3. Let's say you have a total of 100 students. The mean marks is 25, and out of 100 students 80% passed. In this case you don't have standard deviation that is given in the question. Instead you have a proportion, so you can use this proportion to find standard error. Standard error by proportion is equals to root under pq divided by n. This is the formula that you need to know. Again, what do various symbols mean? P basically means proportion, q means 1 minus p, and n is n, number of observation or the number of students. So you can put the values. For p it's 80%. You can put, wait, let me show you. For p 80%, which is 80 by 100, which is 0.8, times q, which is 1 minus 0.8 or 0.2, divided by n, which is 100, and you will get your answer. Number 4. Now let's say two different classes has been given. Class number 1 with 100 students, mean marks of 25, and altogether 80% passed. Class 2 with 200 students, mean marks of 30 and 90% passed. So you have proportion. In proportion, you can apply the formula standard error by difference between proportion is equals to root under. Here, since this part is already under the root, in this case, you had to first bring this formula under the root and then start adding from the right. Here, since this much part is already under the root, you can start adding from the right itself. So you can now write P1 Q1 by N1 plus P2 Q2 by N2. If there's more, you can keep on adding to the right. So this is the standard error by proportion, by difference between proportion. Okay, one last time. Standard error by mean is equals to standard deviation divided by root under n, or sigma by root under n. Standard error by difference between mean is equals to, first you have to bring this under root. How? Sigma by root n whole squared. Wait, let me write it properly. So there's your sigma by root n whole square root under, which means the same thing. You first squared it and then kept it under the root. It will come out to be root under sigma square divided by n. So you can use that formula, sigma square divided by n for first plus sigma square divided by n for second. Then standard error by proportion. This is equals to root under pq by n. Standard error by difference between proportion. This is simply, you can keep on adding to the right under the square root, p1 q1 by n1 plus P2 Q2 by N2. And that's all you need to know for measures of dispersion.